Mr. Harris here, and welcome to a new video. In this video, we're going to tackle some other type of questions that you might see in your past papers or in the DSE. So, which of the following contains the largest number of anions? Now, let us recall what are anions. Anions are those that make you cry, because onions, right? Onions, they make you cry when you're, especially when you're chopping them. That's why it's negative. Or you can try and look at this meme. You see a very cute cat. Cations are positive. Remember, cats have paws. So yeah, hopefully this will now you'll never forget what are cations and what are anions. Anyway, let's tackle the question now. I have 1 mole of CuSO4 and they're asking me to find the anions. So what I'm going to do is, we're going to do the same thing, the three-step method. The first step in the previous video we learned was to figure out what the charges was. Here, we're already given the chemical formula, so we can skip step 1. We've done with step 2 as well. We've figured out the chemical formula. Now I just need to know how many anions are there. So for CuSO4, so I'll write it here, CuSO4, I just have one anion, right? I just have one anion because you don't see any number beyond the 4 here. The 4, remember here, is just for the oxygen atom. So I just have one. So what's the overall number of moles for the anion? Remember, I'll first take the overall compound's number of moles, which is 1 times. I'm still using the same highlighter. If you watched the previous video, I was using this highlighter. I'm going to still use this same one. And then after you've used that number of moles, so how many anions do I have here? Just one. So 1 times 1. And then obviously because we're finding, this time we're not finding the number of moles, but we're finding the number of particles. In this case, the number of anions. So actually I'm going to times it by Avogadro's number. So to keep things simple, I'm not going to use 6.02 times 10 over 23. We know that we could just represent it with L. So here, what's 1 times 1 times L? So just 1L. So actually it's just L, but let's keep the number here because we're doing MC. It's for our own benefit. All right, B. How about for 1 mole of Na2CO3? So Na2CO3, is there any number beyond the CO3? No, that means I just have one anion again. So our target is just one anion. So again here, I'll first start off with my overall mole and times it by the number of anion. Here again, I just have one anion. And then times it by Avogadro's number. Here, it's also the answer is 1L. All right, now let's do C. C this time, I have 2 moles of CaNO32. So CaNO32. So the anions obviously is the nitrate ion, because I know nitrate ions NO3 minus. How many nitrate ions are there? You see this time here, there's a number 2 here. That means there are 2 nitrate ions. 1, 2. All right, now let's find the number of anions then. First off, this time also, there are 2 moles for the entire compound. So 2 times it by the number of anions here. I have 2 of them. All right, and times it by L. So this one is actually 4L. And for D, we'll do the same thing. Now here you'll say, sir, this is HCl. Is HCl, isn't that hydrochloric acid? Isn't it like a covalent compound? Now, there's also some thing called hydrogen chloride gas. So we'll leave it for now, but let's just imagine that this is an ionic compound. So HCl, obviously the Cl would be chloride ion. Chloride ion, there's just one of them here. You don't see any number here, so there's just one of them. So for D here, so original number is 2 moles. 2 times, what's the number of anion? Just one of them, times it by L. This one is 2L. So obviously you can see here our answer should be, with the large number of anions, you'll obviously see that it'll be the 4 times 6.02 times 10 to the power 23. So the answer for this is C. So that's how you're going to do it. All right? So now let's move on to another question. How many atoms are present in 0.3 moles of carbon dioxide molecules? All right. So the original number of moles I have is 0.3. So let's do that. 0.3. And then they're asking us the number of moles to find the atoms, right? So our next step is to see how many atoms are actually there in carbon dioxide. Carbon dioxide we know is CO2. Now they're not asking us ions anymore. They're asking us about atoms. How many atoms do we have? Here I have one carbon atom. And what does this O2 mean? It basically means that there are two oxygen atoms. So I have one carbon atom, and I have two oxygen atoms. So in total, I have three. So in other words, this is going to be times by 3. And then afterwards, obviously, because this is just the number of moles of carbon atoms. Remember, this was how you can find a number of moles of carbon atoms. Now they're asking you about the number of particles. This is the particles that they're asking. Particles. So in other words, you need to times it by L, which is 6. Oh, this time you're asked to find the actual answer. So maybe I'll write the actual answer here. So it will be basically 0.9 times by 6.02 times by 23, because 0.3 times 3 is 0.9, and L is, as we know, L is 6.02 times 10 to the power 23. And then when you do, I think just based on here, quite easy to see that the answer for this would be D. All right, so here I skipped quite a bit of steps. So how did I get 0.3 was the original mole of the entire compound. And why did I times it by 3? I times it by 3 because I wanted to find a number of moles of carbon and oxygen atoms for the entire thing. And why did I times it by L? It's to find the number of particles, in this case, the number of atoms. So I've incorporated everything that we learned in the first 4 or 5 videos. Now moving on, question 10. This time, they're not asking us atoms, they're asking us about ions. But we're going to follow the same steps because remember, these are all just to find the number of particles. So first step here is to obviously write down the overall mole of the entire compound, which is 4, and times it by whatever number of ions there are in this compound. This time they're asking you calcium nitrate. So follow the 3-step method. Now you're not given the chemical formula, so you need to figure out the chemical formula. Calcium group 1, sorry, group 2, so it's 2 plus. Nitrate, this time it's not nitride like in the previous video, it's nitrate. So nitrate we know is NO3 minus. Do it across method. Bring the numbers to the other side. Here I have Ca just a 1 because there's no number there, so I'm not going to write it. But for nitrate, I know that there's going to be a 2. All right, so what does this mean? This means that I have 1 calcium ion. And how many nitrate ions? You can see there's a 2 here. I have 2 nitrate ions. All right. Now, what's the number of moles of ions for this entire particle? Sorry, for this entire compound. I have 1, 2, 3. So it's going to be 4 times 3. Okay, that's the number of moles of calcium nitrate ions here. Let's just say that. And then after you find the number of moles of the ions here, then you're asking you to find the particles. So just times it by L. So times by 6.02 times 10 to the power 23. Okay. So it's going to be 12 times 6.02 times 10 to the power 23. And I think, oh yes, 7.22 times 10 to the power 24. So I'm just cheating. I'm just looking at the answers and getting it, but you can use your calculator to double check by yourselves. All right, but this is how you do these steps. Again, how did I get the 4? The 4 always start off with our original number of moles of the compound, and then you look for what the question is asking you. If they're asking you for ions, then you need to find how many number of moles of ions are there. Here there are ions meaning both positive and negative. I have 1, 2, and 3. That's why there's a 3 here. And at the end, because they're asking us for the number of particles, and we have learned that the number of particles we need to times it by L, and that's how we can get the answer. So this one, question 8, 1 mole of potassium sulfide contains, and you're given a bunch of options. Potassium sulfide, again, the three-step process. Think about the chemical formula and figure out how many ions are there in potassium sulfide. So potassium is group 1, K plus. Sulfide, on the other hand, is group 6. Yes, group 6. So S2 minus. K plus and S2 minus here. Do the cross method. All right, cross method. I think by now you should be very familiar with it if you watched all the videos. So here, K, the number is down here is 2. For S, it's just 1, but we're not going to write the 1. So here, what does this K2S mean? It means that I have 2 potassium ions. So let me write 2 of them, and this S means that there's just 1 sulfide ion, S2 minus. All right, now let's look at our question. So originally I had 1 mole of potassium sulfide. Since that it contains 2 moles of potassium ions, is that true? Let's see. So do I have 2 moles of potassium ion? So originally I had 1 times, and how many potassium ions do I have here? So let me use this color. Here I have 1, 2. So 1 times 2, this for potassium ion, this is indeed true. I have 2 moles of potassium ions, which in other words, we are talking about the cation. So this first part of this statement is correct. And I have 1 mole of sulfide ions. Is that true? So let's see. Sulfide ion, on the other hand, it's here. Sulfide ions, it's just 1 here. So in other words, it's just going to be 1 times 1, because I only have 1 sulfide ion. So this is also true. I have 1 mole of sulfide ion, or sulfide ions. So actually the answer immediately is A. And the others, you can see, why is this wrong? Because it's not, you're not only just having 6.02 times 10 to the power 23 potassium ions, you're supposed to have, because remember it's 2 moles here, so it's going to be 2 times 6.02 times 10 to the power 23. So that's why this is wrong. And you can see here for sulfide ions, it's not going to be 2 times that. I've just found that there's just 1 mole, so it's just going to be 1 times. Not 2 times, but 1 time. So C, it says there are equal number of potassium ions. Obviously not. If there are 2 moles of potassium ions and 1 mole, how can that even be equal? And for D, it says you have 1 mole of potassium ion. No, it's the opposite. It should be 2 moles, and this is 1 mole. So there you go. All right, and then let's do this last question, and I think you'll be very, very familiar with how to tackle all of these. So, which of the following contains the largest number of moles of ions? So again, this time they're not asking you to find the number of particles. They're asking you to find the number of moles. So we can just stop before doing times L. You don't need to do times L, in other words. So here, first step is to see or to figure out the 3-step process again. So how many ions are there for chromium 3 sulfate? Chromium 3 sulfate, I'll do it down here. Chromium 3, obviously it's a big help that they're telling you is having a 3 plus charge. You're like, sir, well, how do you know it's a 3 plus charge? Why isn't it a 3 negative charge? Because remember, obviously ions, one of them has to be a positive, the other one has to be a negative. The other one, we all know sulfate ion is SO4 2 minus. We all know that. So that's why the other one has to be positive. Even though you've never seen chromium 3 or heard of it before, doesn't matter. Do the cross method, and you should get that this is Cr, the 2 comes down, and I have SO4 3. So what does this mean? What does this mean? This means that I have 2 chromium ions, right? I have 2 chromium ions, and what does this 3 mean here? Obviously, it means that I have 3 sulfate ions. SO4 2 minus, SO4 2 minus, SO4 2 minus. There you go. All right, now it says I have 1 mole of chromium 3 sulfate. So I'll always remember, always start off with the original number of moles. So 1 times here, how many ions do I have? 1, 2, 3, 4, 5. So 1 times 5, so I have 5 moles of ions. All right, I'm not going to write the whole thing. So you can do the same thing for the others. So find which one would have the highest number. So for B, calcium phosphate now. So I'm going to rub this part out. And let's see for calcium phosphate. So calcium is Ca2 plus, phosphate is PO4 3 minus. This is another polyatomic ion that you need to know it's having a PO4 with a 3 negative charge. So memorize this also. So again, cross method. All right, this time I'm going to speed up. So you will get Ca3PO4 2. So what does it mean? It means that I have 3 calcium ions. Okay. And what does this other one mean? It means I have 2 phosphate ions. So again, oh, not again, this time it is 2 moles. So 2 moles of calcium phosphate. So 2 times, and how many ions I have? You can see I have 1, 2, 3, 5 again. 2 times 5 this time. Obviously, it's a big number. It's going to be 10. This is 10 moles of ions. Of ions. Later on, I'll just write it, but you know it's ions. For C, you can do the same thing. For C, zinc sulfide. Zinc sulfide, how do you do that? Zinc, you should know that it's 2 plus. Sulfide, it's not sulfate anymore, nor sulfite. It's with an IDE. So it's the sulfur ion, which is sulfide ion. Here, do the cross method, and later on you get this is ZNS. Sorry, not ZNS. ZNS, ZN2S2. You can cross cancel out the 2 because they are being simplified. So you have ZNS here. So what does this mean? I just have 1 zinc ion. I have 1 sulfide ion. So in other words, it's just simply 3 times 2 here. 3 times 2. Because I have 1, 2. So just 2 ions. So 6 moles. And then finally for D here. So 4 times, oh, calcium carbonate. Calcium carbonate, okay, all of you, if you watched the previous video, you already know what calcium carbonate is. So Ca2 plus and Ca3 2 minus. And I'm not even going to write the cross method, but we know it is CaCO3. So calcium is Ca2 plus, carbonate is CO3 2 minus. There's just one of them because you don't see any number here. So in other words, it's going to be 4 times, I already wrote the 4 there for you. 4 times, how many do I have? 1, 2. So actually I have 8 moles here only. So based on this answer, remember they're just talking about the number of moles of ions, so I don't need to find the number of particles here. So the answer for this should be, let's see, B. Okay, so for these type of questions, remember always incorporate this 3-step method and look for the original number of moles of the compound. Always it'll be most likely provided to you. If not, then you need to use the number of moles is equal to mass over molar mass formula. And then look for if they're asking you to find the number of moles of any particular particle. If it's like ions or atoms, then you just count how many there are. And if they're asking you for the number of that atom or ion, that's when you're going to times it by L. So this is how you use all of these formulas together. So it's a wrap for this video. I'll see you in the next one. Bye.